Hello interwebs, welcome to Let's Fix Computers. I have got an Asus something here. This is a UX310u laptop that has no power. So we're going to have a look at this and see what's wrong with it. I have already had a quick look on the inside just as a viability check. I tend to just take the backs off of the laptops before I start recording these days, just so I can determine whether this is something that I'm actually going to get a video out of or not, because there's so many false starts and it's very annoying. So yeah, that's why the screws are already out on this one, so I kind of know what's coming up, but stay with me. Anyway, so let's plug a power cable in, and if we have a look at the Paul Daniels meter, you can see that we've got power going in, but we're only pulling 14 milliamps, and that's actually just the quiescent current on my Type-C to DC adapter. If I unplug, as you can see, we're still pulling 13 to 14 milliamps. So there's functionally zero current draw from the laptop. And in addition to that, like, it goes without saying, but there's no charge light on the side there. None of the lights come on at all. So the laptop is stone dead. If we flip the laptop over, we'll find that someone has already very kindly taken the screws out the bottom for me. So we'll take the back cover off. Oh no, it's clipped back down again. This one was stubborn. Get off. There we go. And the first thing we're going to do is just pop out that battery, which conveniently I've already removed the screws for. And whenever we have a laptop that has no power, the first thing we're going to want to do is check for a main rail short, because more often than not on the straightforward ones, that's exactly what you're going to see. So you're going to want to get your multimeter into resistance mode, put a black probe on a screw hole somewhere. Let's pick that one up there. And we're going to look for somewhere to probe. So let me just zoom down a little bit. And a good place to do your main rail probe is to look for CPU vCore. So here's our CPU, and nearby you're going to find a cluster of power components. So we've got inductors, MOSFETs, capacitors, power related stuff. And you're going to want to move to the input side of the VRMs. So we've got the CPU. This is all input to the CPU. We've got the inductors, then we have the MOSFETs. And so we're going all the way, we're going away from the CPU to the other side of the MOSFETs. And this is where we're going to find the actual main rail going into this power conversion area. So on this laptop, we've got a nice big 25 volt capacitor here. That's going to be on the main power rail because it's 25 volts. So you're looking for large capacitors that are going into these MOSFETs. So if we check the stripe side, we should find that that is ground, which it is. And let's check the other side. And that's not shorted. So, okay, it's not a main rail short then. Okay. Well, how far is the power getting then? Not going to lie, when I did my assessment, I measured the wrong side of the capacitor and I thought this was going to be a main rail short. Whoops. Let's back out and let's just plug the power back in. And let's just see how far it's getting. So I'm going to go over to voltage mode now. And I'm going to just check that same capacitor and just see if there's power going to it. And no, the main power rail is not coming on. Okay, well, let's see how far the power is actually getting then. So let's move up to the top corner here. So in the top corner, here's our power connector. So we should have 20 volts coming in on this big central pin. Yeah, there's our 20 volts. Okay. Now, that is going through to the other side of the board, so we can't measure a lot there. We have got a MOSFET here though, which is probably one of our DC in MOSFETs. So let's see if there's some power there. Nothing there. What about the other side? Nothing there either. Okay. It looks like we're not going to get a lot of help from this side of the board. So I tell you what I'm going to do. I'm going to roll the intro and we're going to take the motherboard out of the laptop so we can take a closer look at it. Let's go. Now we've got the motherboard out, let's take a closer look in this corner. This is where the DC jack is, so I can zoom in on this guy here, and you can see we've got power-related stuff, so we've got something a bit more useful to measure. I'm going to come under the microscope so we can look closer at this and give you guys a better view. So let's follow the power. I've got a DC jack plugged in. So let's see where our power is appearing. We've got ground on top of this guy, and we've got 20 volts there. Yeah. So we're going to follow that down to here, where we've got some input inductors. These guys suppress spark, static, just jolts of power when you initially plug the connector in. So let's check the other side of these guys. Yeah, 19 volts. And then we come to this pad here. Now we've got a couple of 2.2 ohm resistors here going off to somewhere. But also we've got this little cluster of vias on the board. So let's just check the other side of the board, see where they pop up. And they're coming up on this guy here. So this is going to be our first DC in MOSFET. And so if we check the input there, there we go. There's our 20 volts. I wasn't getting that when I checked in. I didn't see that at first when I checked. Maybe I wasn't probing properly. There's not a lot of accessible pin space here, and there's that sort of crusty deposit that you get on motherboards, which is like old flux or cleaning fluid or something like that. So sometimes you just don't get a good probe. So there's 20 volts there. Is it getting out the other side? No. Okay, so this guy isn't turning on. Let's check its gate. The gate is 0. So this is an N-channel MOSFET, and I can tell because the power is flowing from the source to the drain. The source is the 4-pin side, and the drain is the 3-pin plus gate side. So there should be power on the gate to switch on this MOSFET, and there isn't. So the chip controlling, or the circuit controlling this MOSFET is opting to not turn it on. This is the point where people will often just bridge out this MOSFET. They'll just take the MOSFET out and just solder blob across the tracks. And if you do that, there's a pretty good chance that the laptop will switch on. However, the laptop almost certainly won't charge its battery, and you might get other weird effects because the power system in the laptop is not turning on for a reason. It's detecting a fault. And so even if you force power into the laptop so the rest of it switches on, the power management chip that is doing battery charging and stuff like that is still going to be like, no, I'm still not doing anything. There is still a problem here. You may have bypassed me, you've gone over my head, but I'm still not going to charge the battery. So why might that be? Well, let's unplug the power, and we're going to check if this guy is behaving properly. And on the other side, where we've got the other DC in MOSFET, we're going to check if this guy is working properly. So let's go up to resistance mode. So as we saw before, if we check the output from the DC MOSFETs, we go into a current sense resistor and we become the main power rail, and that's not shorted. So it's not a short circuit that is causing the DC MOSFETs to not switch on. So maybe there's a problem with one of them. So to check for this, I'm going to put my multimeter into diode mode. So we've got the little diode symbol at the top there. And I'm going to swap my probes around. And we're going to check across those DC in MOSFETs. So let's start with this one here. So I always forget which way round you need to check, but what we'll do is we'll find in one direction, as you can see, we have a 0.52 diode drop. This is the body diode of the MOSFET. Due to the way that MOSFETs work, from drain to source, you will see the effect of a diode there. There isn't actually a diode in there, but it has the same effect as one. So you see that 0.5 diode drop from my red probe to the black probe. So that's what we're seeing there. And if we check the other way around, we should find that there is no power going through. So there you go, that's open line. So this is obviously the blocking effect of the MOSFET. If the MOSFET doesn't turn on, no power flows. So that guy is behaving as we would expect. So what about the other one? We'll do the same test up here. So this guy. So once again, let's see. So this guy's the other way around. So I'm going to go from drain to source again. Oh, and that's just shorted through. And we'll check it around the other direction for posterity. And yeah, it's still shorted. So this MOSFET has just shorted through. That's why the laptop is not turning on, because the power management chip is detecting a fault with this MOSFET. So that's our problem. So we need to take this guy off the board, and if we replace it, it'll probably be fine. So let's start by taking it off the board, and then I need to rummage through my breaker pile and see if I can find a suitable MOSFET that will fit there. So let's get our old MOSFET off the board. Reflux. Here comes the hot air. Maximum airflow, 420 degrees. Die. And now for my donor MOSFET, I've grabbed one of my breaker boards here. Hi HP with a dead CPU, nice to see you again. And let's go up to the DC in section here. This is where the DC in jack connects to on this laptop, and if we follow it up, we've got a out of focus section. If we follow the trace up here, we've got a TVS diode here protecting it from static shocks and stuff like that. We've got our first DC in MOSFET, then that guy goes into a second DC in MOSFET, and then we start going into the rest of the laptop. So we go out of this MOSFET and then back down through that current sense resistor, and there's at the start of our main power rail. This laptop then does more stuff with it, but that doesn't matter to us. This MOSFET here then goes to the battery connector. So this guy here is the correct form factor for us. Now, for MOSFETs, obviously you might say, well, is that the same MOSFET? No. However, this is a DC in MOSFET. It's not doing a whole lot. The DC in MOSFETs are kind of just barriers, to be honest. They're just gating the power coming into the laptop. For DC in MOSFETs that will actually be doing power conversion, like this guy, like these guys, like power stages over here and that kind of thing, we do need to be paying attention as to what kind of MOSFET we're fitting. But for this DC in MOSFET, this general purpose one from another laptop will be fine. They're going to have the same rating on them or close to. The stuff that we really care about, like RDS on and that kind of thing, doesn't particularly matter when you're not actually doing any power conversion, to my knowledge. People might tell me I'm wrong. If this is a crime, tell me in the comments, but I believe that this guy will be fine. So I'm going to turn this board around so I can blow away from plastic connectors. And I'm going to take that guy off the board. And And I've forgotten which way around this guy goes already. Okay, that goes that way around. Please get off the tweezers. There we go. Some more flux. Cartoon splat noise. And hot air. I'm going to turn down my airflow a little bit now. Try and roughly hold this guy in place while it starts to flow. That'll do. Right. I'll just quickly check that we are electrically sound, and then we'll clean up. So back into diode mode. And we should get our diode drop. Oh no, we're the other way around. So yeah, we've got no current flow in that direction. That's correct. So this guy needs to open up to let current go through it. And then there's our diode drop in the other direction. Cool. Cool. So let's get this all plugged in and let's see if we have achieved anything. So I want two things. I want the battery. That's going to go around that way. That's going to go in like that. Just arranging everything so it's as it would be in the laptop. So hopefully this doesn't explode. Cool. So the Paul Daniels meter is showing current draw now. So the laptop is doing stuff, and at about 400 milliamps, I'd expect that to be powering on or just otherwise posting. So we've got a little bit of warmth on the CPU as well. So yeah, that's doing stuff. And let's plug in the battery and see if it'll charge the battery. Yeah. There was a step in current then. There we go, and it just banged up to 2 amps. So it's charging the battery, and we have fan spin, just so you know it's definitely on. Excellent. This works. Let's put everything back in the laptop, folks. Right, power in, and we've got charge lights and power lights on the side. Very nice. We've got 2 amps. Oh, well, we had 2 amps. There we go. Yep, it power cycled. That's fine. And now we've got a boot logo, and it's booting up. Cool. Charge looks slightly wonky, but that's because I'm not using the correct charger for this thing, where I'm trying to plug it through in via the Paul Daniels meter. So that's why the charge is kind of all over the place. Late breaking update, you'll notice that I've got the laptop in pieces again, and that's because after I stopped recording, the laptop was not consistently charging. It kept cutting in and out to the point where it just was not working properly. And I was like, oh, okay, that's not done. And I had spotted a little bit of hiccuping while I was recording, but I thought, oh, that's going to clear up. It's just because it's upset and the battery is flat and stuff like that. So I didn't say anything about it. However, afterwards, the laptop was just demonstrably just not there yet. It was staying powered on, but yeah, the input was still pretty crappy. So I want to demonstrate something that I've just quickly done a check on. So if I plug the Paul Daniels meter back in again, let's just see what that does. So it's working, and we'll just watch this for a bit. It's going to behave now, isn't it? Yeah, okay. What if I wobble the connector? Oh, I don't believe it. It's fine. Okay, I hate it. All right. Well, what I was seeing is that it was hit and miss when I was using the DC input jack. And so what I did was I soldered jumper cables just onto the back of the jack and connected that to my DC bench supply, which is currently off. And when I powered it from the DC bench supply, it was solid as a rock. So long story short is, I think this DC jack is also knackered, and that's extremely common. These things wear out. So I think that DC jack needs to be replaced, and I think a spotty connection there might have been what blew up the DC input MOSFETs in the first place. They just didn't like the stuttery connection or something along those lines. That's my guess. However, Sod's Law says the moment I turn the cameras on again, it's now running solid as a rock just on the DC input. On the jack. So, whatever. Fine, whatever. I'm going to replace that DC jack anyway, because if it's going to be intermittent, then it's got to change. So yeah. Anyway, that's just the last bit on the back end here. I'll skip to the goodbyes now, but just so you're aware, I think the DC jack is bad as well, and I'm going to replace that. Right, so that's that one, everyone. Thanks for tuning in. First time I've actually done a DC MOSFET repair on the channel, surprisingly enough. It's not the first time I've encountered it, but it's the first time I've had the cameras on when I did. And so, yeah, this is an interesting one where you really want to be checking those MOSFETs in diode mode to see whether they're actually working properly, because all these MOSFETs are really doing, like I say, they're just gating the charger input. So it's really easy to wonder how they could be causing problems when power flows or it doesn't, or in this case, because the faulty DC in MOSFET was shorted through, you would still get continuity through it, and you could still, like, if we just jumpered, if we bridged out the first DC in MOSFET, power would flow through this one, and you'd think that it would be working. But it's not supposed to be shorted through. So that's the importance of checking, not for a short to ground there, but a short through. So I hope that was kind of useful. Thank you very much for tuning in, and I'll see you guys next time. Bye for now.